Volcanoes have been both revered and feared throughout history. They're often viewed as a sign of raw natural power that we can't control. And it's true that in some ways we can't. Even today, scientists can't predict exactly when a volcano will erupt. But artificial intelligence might be able to do what humans can't, or at least lend a hand with early warning systems so we can better prepare for the next eruption. But to do that, we need to look at past eruptions and learn from them. Hi, I'm here with MinuteEarth. There are more than 1,500 potentially active volcanoes on Earth, but they're not all created equal. Scientists categorize volcanoes based on how they erupt, how runny their lava is, and where they're located. And each type behaves a little differently. So studying a bunch of different kinds of volcanoes helps scientists understand them all better. Take Mount Vesuvius, which famously erupted in 79 AD and wiped the city of Pompeii off the map. It's a stratovolcano, also called a composite volcano, built up of alternating layers of ash and lava. Most of the really dangerous volcanic eruptions in history have been caused by these types of volcanoes because they tend to have viscous, sticky lava that doesn't flow very far, but instead creates explosive eruptions. On the other hand, shield volcanoes are made of runny lava that flows easily, creating wide, gently sloping sides. They aren't usually as explosive because there's less pressure building up underneath them. But all volcanoes have one thing in common. They release material from deep within the Earth, hot, molten rock called magma, which is formed when rock deep in the planet melts due to high temperatures and pressures. As this magma makes its way to the surface, it often squeezes through cracks in the surrounding rock. And this squeezing releases gases dissolved in the magma, which can make the magma less dense and even more gas bubbles form. Eventually, the pressure from these gases overcomes the strength of the rocks above it, and the volcano erupts. But even though all volcanoes work basically the same way, they don't all erupt the same way. Some rumble and grumble for weeks or months before a major eruption, while others don't give any noticeable warning at all. Studying these differences could help scientists improve our ability to predict volcanic eruptions, especially if they team up with AI to comb through tons of data. Most volcanoes have been rumbling away for thousands or even millions of years, so there are tons of historical records about them, including written accounts, geologic maps, and aerial photos. But despite having all this information, we still don't always know what's going on beneath the surface. And that's a problem, because knowing what kind of magma is below a volcano and how it's moving can help us forecast an eruption. So some researchers are turning to AI to help interpret all the information we have on volcanoes. In 2023, scientists reported developing an AI system that could identify the type of magma below a volcano based on its location and the frequency of small earthquakes that occur nearby. The idea is that magma moving through the rocks creates these small quakes, but different kinds of magma move in different ways. By analyzing these seismic signals, the AI can identify whether the magma is more likely to cause an explosive eruption or a gentler lava flow. This could help researchers assess which volcanoes are most likely to cause large explosive eruptions and therefore need the most monitoring. But even if we know the type of magma that's below a volcano, it's still tough to tell when it will erupt. To get at this question, other researchers are using AI to analyze written descriptions of historical eruptions and see if they can spot patterns in the lead-up to an eruption. One team trained an AI to recognize warning signs for eruptions at Mount Vesuvius in Indonesia by feeding it descriptions of the volcano's activity in the days leading up to 17 eruptions that happened between 1844 and 2020. The AI was able to identify key phrases in the text, like increased sulfur dioxide emissions and rising lake water levels, which together were good indicators of an impending eruption. The team is now working on an app that will allow local officials to input recent observations of the volcano and get an estimate of the probability of an eruption in the near future. Ideally, this tool will help them make decisions about evacuations and other safety measures. While these methods are being developed, other researchers are using AI to analyze physical clues left behind by volcanoes. In 2022, Scientists reported creating an AI that could use satellite images to track changes in the shape of a volcano over time. By combining this information with measurements of gas emissions, the AI can help identify volcanoes that are getting ready to blow. The system has been tested on several volcanoes in Italy and Japan and has shown that it can accurately identify volcanoes that have erupted in the past 10 years. Importantly, it can do this with just 2 days' notice, which would be enough time to get people out of the danger zone. Of course, AI isn't going to replace volcanologists anytime soon. These tools are meant to supplement their expertise and help them sift through the massive amounts of data they collect. But the tools may become more important as climate change causes rising sea levels and more people move to live near volcanoes. And some volcanoes may start acting differently as the climate changes, which means scientists will need to continue learning about them. For example, Mount Vesuvius, which we mentioned earlier, usually has a lava lake at the top of its crater, but in 2023, the lava lake mysteriously disappeared. Without warning, similar things have happened at other volcanoes around the world in the past few decades, and scientists think it might be related to rising temperatures. If these changes become more common, new AI tools will help scientists and communities stay on top of the threat posed by volcanoes. And it's not just volcanoes that we want to keep an eye on. Understanding the processes happening deep in the Earth is critical to understanding our entire planet, which is why Brilliant has a course all about it. In Brilliant's Inside the Earth course, you'll explore the structure of Earth's interior and discover how scientists learn about the planet's inner layers through seismic waves. You'll learn about the different types of waves, how they move through the Earth, and what happens when they hit Earth's boundary. And if you complete this course and you're still hungry for more, you can take all your learnings to the next level with the follow-up Earth's Dynamic Systems course. That's where you'll model how the atmosphere, hydrosphere, lithosphere and biosphere interact with each other. There are lots of fun interactive visuals and no tests. So go at your own pace and get creative with how you learn. And that's the best way to learn something new.